Good day, students. Today, you shall discover new science concept, specifically on how to locate epicenter using triangulation method. This video will serve as a refresher course on module number 2 as well as introduce to you the lesson in locating epicenter of the earthquake for module number 3. If you are to recall module number 2, the objective of module number 2 were to name the different tectonic plates and describe the movement of plate using plate tectonic map. So this will serve as a refresher course for module number 2. And then for module number 3, we have the following targets: to compute mathematically the distance of an epicenter and locate the epicenter using the triangulation method. Let's start with plate tectonics. In the picture that you can see in the video, there are 5 spheres, but we shall focus with lithosphere in discussing the concept in plate tectonics. In plate tectonics, you need to understand how and why several features of the Earth continuously change due to the events which give rise to the mountain ranges, volcanoes, earthquake belts, and others. As discussed in the previous module, lithosphere is composed of crust and the upper part of the mantle. And then crust is made up of a variety of solid rocks with average density of 2.8 gram per cubic centimeter and a thickness that ranges from 5 to 50 km. There are 2 kinds of crust, the continental and then the oceanic crust. They differ in terms of thickness and density. In studying the concept of plate tectonics, we need to understand the definition of plates. The plates are the upper part of the Earth's crust that are broken down into units. They move independently from one another. What are the 7 major plates? As mentioned in your previous module, we have the North American plate, South American plate, Eurasian plate, African plate, Indian plate, Pacific plate, and Antarctic plate. These are the 7 major plates. But aside from that, there are numerous microplates, including the Philippine plate. As you can see in the diagram or picture, we have numerous plates. Also, it was mentioned that plates are moving. They move very slowly but constantly. This movement is called tectonics. That's why when we speak of plate tectonics, it is simply the movement of plates. As you can see in the illustration presented, we can see different arrows. These arrows show the different movement of plates. They can move toward each other, away, or they can even strike slip from one another. As mentioned, this video lesson will teach you how to apply the triangulation method in order to find the earthquake epicenter. Before we proceed directly to that lesson, you need to understand first the anatomy of an earthquake. You can see in the illustration the definitions of terms like fault, epicenter, focus, plates, and seismic waves. Kindly read them. The epicenter is actually the point directly above the focus. The focus or the hypocenter is the origin of the earthquake. As you learned in your lesson during your grade 8, seismic waves are created and generated when there is a significant movement beneath the ground, and this results to the shaking and trembling of the ground. There are things that you need to know before you learn how to locate the earthquake epicenter. Let's begin with the different types of seismic waves. Let's start with P waves. P waves or primary waves, also known as compression waves, vibrate parallel to the direction of movement. Try to imagine the movement of a toy spring or slinky. They travel faster compared to the S waves, and they can travel through solid liquids and gases. Meanwhile, S wave, known as secondary wave or shear waves, they vibrate side to side to the direction of the wave where they move. They are slower than P waves. And aside from that, they travel through solids only. Again, P wave is for primary waves, S wave is for secondary waves. We need also to differentiate the difference between seismograph and seismogram. Now, let's proceed to the challenging part in your module. Activity number 1, lag time. As you can see in the diagram, we have there 4 seismic stations, namely Chicago, Kansas City, Santa Barbara, and Seattle. You simply need to fill in information for column for P wave, S wave, and lag time. Just use the seismogram in order to determine the P wave and the S wave. After that, you can now derive or get the lag time by just getting the difference between S wave and P wave. After getting the time difference or the lag time, you can now proceed to activity number 2, how far I'll go. In this activity, you simply need to apply the formula D is equal to time difference divided by 8 seconds times 100 kilometer. This formula is derived experimentally. The formula is suited because 8 seconds is the interval between the arrival time of primary and secondary wave at 100 km. There is an activity in the module entitled the Epicenter, wherein the objective is for you to locate the epicenter of the earthquake using triangulation method. Only you need to follow correctly the procedures there. This is what you're gonna do in the activity. If you are given a map, you need only to apply the so-called triangulation method, wherein you will apply that in 3 seismic stations. Using ruler, compass, pencil, you will apply the said method. And with the use of the time difference or the lag time between the arrival time of P wave and S wave, you will compute for the distance of the epicenter from the station. You need to find the distance of the epicenter from the station using the formula time difference divided by 8 seconds times 100 km in order to get them. For example, for Batangas, you need to substitute 44.8 for the time difference. After that, you need to choose one of the recording stations and measure the computed distance on the map scale. For example, you will use 1.5 cm for every 200 km. And then after that, you need to set your compass for that computed distance. You cannot measure kilometer in the map in your module since it's very small. That's why you need to use a proper scaling. After that, you need to center your compass on the station you have chosen, and then you will draw a circle. Again, you will use compass and at the same time, ruler. You need to repeat steps 3 and 4 for the rest of the stations. Remember, you should get 3 circles that intersect or nearly intersect with each other. This intersection is known as the epicenter. The importance of locating epicenter is that it will pinpoint which fault line is active. You need to find the intersection among the 3 circles, and that's the epicenter. So to sum up, you need to locate the epicenter using the 3 seismogram records. Note that you need to get the difference in the arrival time between the P wave and the S wave. You can also record their difference using a particular graph, as presented. Just subtract the arrival time of the 2 waves in order to get the time difference. You can plot them in a travel time graph for you also to determine the time difference. Consider the diagram there. After you get the time difference, you can now get the distance of the epicenter from each seismic station using the formula I stated a while ago. The intersection point among the three is the epicenter of the earthquake. So I guess you can now perform activity that is entitled the epicenter. Using that map, you need to trace that in your paper in order to apply the triangulation method. No need for you to compute for the distance of the epicenter from each station because it's already given in the table. I guess you can now answer the following essential questions after understanding the topic. Why do we need to study plate tectonics? What is lithosphere? The difference between two types of crust? How are plates moving? And why do we need to find the epicenter of the earthquake? That's it. Thank you for watching this video. And I hope you learned something today. Thank you, students. Goodbye.